Hey guys, we're going to be working with operations on complex numbers. That's section 5.9. As always, here's some vocabulary for you. Try not to be too discouraged because this again does facilitate your learning, looking up definitions and examples in the glossary on that online textbook, or really a PDF once downloaded. Okay, so all these will really help out with the lesson. Anyways, let's go ahead and continue. Okay, so that's something where you can pause the video, write these down, look them up, and make the connections. Because priority here, besides getting the material out in an understandable fashion, it's also to be very efficient here with time. Okay, so anyways, we're going to be looking at problems that say, hey, graph the complex number. When it comes to these, alright, what you want to do is, this is what you guys already know, right? That numbers, all numbers on this planet can be written in the form a plus bi. This is because all numbers are in one form or another a complex number. Okay? So for example, the number 1, right, I'll give you a quick example. The number 1, okay, which we understand is just to be the typical number 1, in the world of complex numbers can be written as 1 plus its imaginary part, which does not exist, as 0i. Alright? So this front part is referring to the real component, and this is the complex component. Alright? Anyways, I don't want to deviate too much. So let's get back on track. Now, one thing I'm going to encourage you guys to do, okay, is as soon as you hear graph the complex number, is to kind of draw your own little graph here. Alright, 1, 2, 3, 4, maybe 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now the next thing you want to do immediately is you want to identify that this is your real axis and this is your imaginary axes. Alright, so then this is going to make graphing these complex numbers a lot easier. Now the other tip I'm going to give you is you want to maybe consider these complex numbers in this form, x plus y I, so that graphing becomes that much more easy. Alright, so let's look at this one. Okay, this one here, if I write it as a complex number, is negative 2 plus 0i. So this is the real part, so I travel negative 2. Okay, up and down it says 0, so I stay right here, and then I label this one. Okay, done. So here's this one. All right, let me try a different color. I'm going to go red. Now this one's already in that form. Okay, so for this one, alright, I'll just underline it. It's 4 along the real axis, so it's 1, 2, 3, 4. Excuse me, 1, 2, 3, 4, and then 2 up on the imaginary axis, 1, 2. So there's that point. Let's go green. Now graph the complex number 4i. This one needs some help, so there's no real component, so I got the 0 plus 4i. Now I can graph it. Okay, so the real component along the real axis is 0, so I stay at the origin. Then I travel 4 up on the imaginary line, and that's where I plot that. And lastly, let's go and look at this guy. He's pretty much in that form already. So now all I do is travel negative 5 on the real axis. So 1, 2, 3, 4, 5. Alright, now I guess what I could do to this one is negative 5 plus 1i, just to reinforce the fact that this is not a 0. Okay, it's a 1. So once again, negative 5 on the real axis, 1, 2, 3, 4, 5, and 1 up, okay, which is that point. Alright, pause the video if need be. Let's go and continue. Find the absolute value. Alright, excuse me. So we're going to find the absolute value of this number. Now this is related to the distance formula, but I don't want to eat up too much time here, so let's just get straightforward. What do you do, mister, is the question, right? So we're going to show you how to compute this, and we can maybe explore the why in class which affords us more time. Okay, so notice what I'm doing is I'm simply substituting this real component up here in the front, all right, and this part in the back here, okay, the imaginary portion, all right, is -9. Now, I do want to show you guys that the -9 itself alone is real, but this combination, okay, is what we could consider the imaginary component. All right. Anyways, so this might look familiar to you guys. It's a distance formula. Again, we can explore that in class. The main thing is, what do we do? And I'm doing it. Okay, simply substitute this value in here, this one in here, and perform the math. 49 plus 81, which equals the square root of 130. Okay, done and done. So if it helps, okay, I'll put a star here. You can consider the formula, okay, for this kind of problem. So let me kind of give you guys a little up here. So essentially, if you're asked to take the absolute value of A plus BI, right, generically, it's equivalent to doing what? Taking A squared plus B squared, the square root of that. Okay? Alright. Now, if you feel like it's too much, guess what? That's why you take really good notes and use them, and then come prepared with questions. If you're following, awesome job. This next one is some of these operations with complex number. This one says subtract, write the result in this form. So ultimately, you must have it in this form. Okay. So let's go and take care of the math portion. Alright, so excuse me once again. We're going to basically subtract these two complex numbers. We must end in this form. So here we go. We're going to have 5 minus 2i. Let's go and distribute this minus sign. Minus 6. Distribute that there. You get minus 8i. Okay, let's go ahead now and combine like terms. You got the 5 minus 6. And you got the minus 2i and the minus 8i. Excuse me. So if we were to combine like terms, right? 5 minus 6 is -1. Excuse me, -2, or I'll explain it two ways. Minus 2i minus 8i is really minus 10i if you understand it in that way. If you don't, we can essentially factor out the I. Okay, so I guess I can write it in there, minus 10i, okay, which is essentially our final answer. But if you can make that jump for some reason, I can write it this way. Okay, 5 minus 6, kind of quantify that. All right, we can distribute out the minus sign, and I'm left with 2 plus 8i. Right? Either way, whatever helps would produce the same answer. So this is -1, and this right here is minus 2 plus 8 is 10i. Okay. So that one's done, and this next one might be the last one. All right, let me double check here. No, we got 2 more. This one says find by graphing on the complex. So when you get to this problem, here's what I'm going to encourage you to do. Is since you're already proven on the previous problem that you can do the math on these complex numbers very easy, go ahead and perform that math. Okay. So this is not a subtraction, it's a sum, right? So let's go ahead and combine like terms. So it's 3 plus -4. And then I've got plus 6i plus -2i. Alright, so let's go ahead and do the math on there. We've got -7, okay, and then plus 6i plus -2i would give you 4i. So that takes care of that in terms of the addition. Now, in terms of graphing, let's kind of maintain that integrity here and kind of see what the link is. Okay, so essentially we got to graph that. So here's the real part. All right, I'll put the symbol for real numbers and symbol for complex numbers. All right, so I'm going to go ahead and again, this is the answer, by the way. Okay, However, they do want us to use graphing, so I'm going to use that to prove why the answer is. This was not as intuitive or straightforward. So if I plot him, it's -3, 1, 2, 3, and 6, 1, 2, 3, 4, 5, 6. Alright, I'm going to plot this next one. So I got 4 and 2 down. Alright. So if I now connect them with the origin, you'll notice that it produces this right angle. Now the rule here to produce this sum by graphing, you're supposed to draw a parallelogram using these 3 points. Alright, and essentially it'd be something like that. Okay, so it's not an exact science, at least not by hand. However, it should be a very close estimate to this sum. And let's just kind of see if we can verify. So there we've got 4, we got about 5, 6, 7, and then 4 up, 1, 2, 3, 4. So roughly about there. Alright. And lastly, multiply 6i times this complex number, write the result for bi. Okay. So let's go ahead and set this up. You've got 6i times 4, which is very obviously 24i. And then you've got, pay attention here, 6i times minus 6i, so you get minus 36. I times I is I squared. Something very important for you guys to know is that I squared equals -1. Alright, so I'm going to start that because that's important. If that seems a little strange, remember this fact is that, what is it, the square root of -1 equals I. You kind of make that connection yourself there. Okay, that's your prior knowledge. So anyways, what I do now is I substitute this I squared with the -1. So I have 24i minus 36 times -1. Right, I squared equals -1. And I have 24i minus, whoops, right, after we multiply with the -1, this now becomes positive, plus 36. And because they want it as a plus bi, or the real part and the imaginary component, I'm going to switch the order and put 36 plus 24i. Guys, thank you for your time. I'll see you in class.